Awesome. And we're back with math with Mr. Hain. All right, so let's talk about parallel line relationships. Okay, so we're going to lead with our essential question. And our essential question is, how can I remember how angles in a set of parallel lines relate to each other? A very important question indeed. And to begin talking about this, we really just have to take a look at a set of parallel lines. All right, so here I have the two black lines, which are completely parallel. Use your imagination. I drew this on my whiteboard. And the light blue line, which indeed is the transversal. So this is just some basic vocabulary to get us started down the path. The transversal here is just the line, straight line that cuts a pair of parallel lines. So it cuts right through them. In all of our examples, I'm going to be referring back to this drawing. 1, 2, 3, 4, 5, 6, 7, and 8 are just angles on that set of parallel lines created by the transversal. Now, you see that the outside of the set of parallel lines I've labeled as the exterior, and the inside of those two lines are labeled as the interior. All right. So this gives us a basis or a point of reference with which we can start talking about what we think is equal. So I like to start just looking at this and just saying, okay, what sets of angles do I think look equal? And I've made some lists. So the corresponding angles 1, 5, 2, 6, 4, 8, 3, and 7. All right, so let's just take a look at these, the corresponding angles. So if I go back, 1, 5, 2, and 6, 3, and 7, 4, and 8. Okay, I immediately notice one thing. 1 and 5, which are equal, 1 being here and 5 being here, are both obtuse. One is exterior and one is interior, and they're on the same side, in this case for 1 and 5, the left side of the transversal. They are also both obtuse. And we're going to come back and revisit this later, and yes, they are equal. And the same kind of thing can be seen and said about angle 4 and angle 8. They are both obtuse. They are both on the right side of the transversal. 8 is exterior and 4 is interior. And the same can be said again about 2 and 6 and 3 and 7, except they are all acute. So in that sense, they are corresponding. That's the name of those angle pairs. One is exterior, one is interior. Both are obtuse or acute, and they're on the same side of the transversal. All right, so let's take a look at alternate exterior and alternate interior angles. So alternate exterior angles are 1 and 8 and 2 and 7. So if we go back, 1 and 8 are both exterior. They're on opposite sides of the transversal, and angle 1 and angle 8 are both obtuse. Angle 2 and angle 7 are also both exterior on opposite sides of the transversal, and both are acute. And if I looked at the pairs on the inside, the interior angles that are on different sides of the transversal, you see that they are also equal. 3 and 6 are both acute. 4 and 5 are also both obtuse. So this leads me to alternate exterior and alternate interior angles, and they are also equal. So these are pairs of equal angles. All right. All right, so let's take a look at the vertical angles. 1, 4, 6, 7, 2, 3, 5, and 8. They are kind of connected and directly across from each other. So let's take a look at what I mean. All right, 1 and 4, 2 and 3, those are vertical pairs. 5 and 8 is a vertical pair, and 6 and 7 is a vertical pair. So if we look just at 1, 2, 3, and 4. All right, 1 and 4. If the blue line and the black line kind of create an X, 1 and 4 are connected because they're formed by the same two lines and not three with the other ones. And they're across from each other on the X. Same thing for 2 and 3. If you look at 6 and 7, they're formed by the black line and the blue line. So just the transversal and one of the parallel lines. And 6 and 7 are both acute, and 5 and 8 are both obtuse. Okay. All right, so that's our vertical angles. So those are the equal sets, corresponding alternate exterior, alternate interior, and vertical. And now let's look at sets of lines that add up to 180. Okay, so there are a ton here. Basically, the key is one is acute and one is obtuse. So let's just look at the first example on this slide, which is 7 and 8. So if we go back, 7 and 8, they're both located here. One is acute and one is obtuse. They are on the same line, the black line, so we know they have to add up to 180. And what you've been noticing is all of the angles that I said that are equal, like just take the ones that are equal to 1, all right? 1 is equal to 5, both obtuse. 1 is equal to 8, both obtuse. So if I look at that for angle 1, we just said that 7 and 8 are 180 degrees when I add them together. But I know angle 1 is equal to angle 7, so that means angle 1 plus angle 7 is also equal to 180 degrees. 7 is acute, 1 is obtuse. So if all the acute angles are equal to each other, and all the vertical angles are equal to each other, then there's some shortcuts that happen here. Any pair of acute angles, well, they're equal. Any pair of obtuse angles, well, they're equal. And remember, this is when we're talking about parallel lines cut by a transversal. Again, parallel lines cut by a transversal. This doesn't work for just two random angles that you draw. All right. Any acute angle plus any obtuse angle must then equal 180 degrees. Because back on our drawing, we can say, if I say 1 and 6 are equal to 180 degrees if I add them up, angle 1 plus angle 6, basically angle 6 is equal to angle 2. And so we see that it just makes a straight line, so it has to be true. Angle 1 plus angle 6 is equal to 180. And that's why we can say any acute plus any obtuse angle equals 180. All right, so those are some shortcuts that help you remember some of those parallel line pairs, and then that leads us to some problems that we can find. So what is a measure of the question mark? So for A, see, I see that they're alternate exterior, but they're both obtuse, so they have to be equal. So the question mark is equal to 110 degrees. And given the second drawing, you can see that they're alternate exterior angles. They're on different sides of the transversal, and both of them are exterior. Sweet. So let's take a look at B. If you said that the question mark was equal to 84 degrees, then you are absolutely correct because both are acute. So they have to be equal. And they're alternate interior angles. Awesome. So this leads us to C, which is definitely different. We see one of them is obtuse, and the question mark is acute. Well, one is obtuse and one is acute. That means that they add up to 180. So 100 plus the question mark equals the question mark is equal to 80 degrees because they have to add up to 180 degrees. In fact, they're consecutive interior angles. All right, let's take a look at D. All right, both of them are obtuse, so they have to be equal. So the question mark has to equal 110, and that's that relationship really just looks like problem B. So there are definitely alternate interior angles. Sweet. So let's go a little bit deeper. This was just kind of like surface level checking for understanding. Let's go to adding algebra into this. All right. So for E, both are obtuse, so they're equal. In fact, they're alternate interior angles. Okay, so that means I can make these two expressions equal to each other. And then solve for x. I mean, I just got to subtract 139 from both sides, and x is -7. All right, easy peasy. Let's take a look at F. All right, look at the angles. They're both obtuse, so they both have to be equal. In fact, they are corresponding. So that means I can take the expressions and set them equal to each other. I'm going to move the smaller x. That leaves me with a variable for a coefficient of x that's positive. All right, subtract 21x from each side. Move that -5 or -5 by doing the inverse, which is addition. And of course, now I've got us divide. All right, cool. So x is equal to 5. Awesome. So these are some basic ways that we can use the equalities of parallel line angles and their relationships. Specifically, we can look back as I rewind the slide presentation to the shortcuts and use these shortcuts to help us solve much more complicated problems like E and F. All right. So that's just a scratch on the surface. There's practice that's later. You can Google online and find tons of practice for parallel line relationships. But until then, if you're in my class and you're writing your notes, write that summary. Make sure your table of contents is updated. And if you're not in my class, and even if you are, let's just make sure that we're keep doing the math.